problems about the lift bolt or ball lift or particle dropped in a lift, in accelerating lift. What is the time taken by the ball to reach certain point in a lift? So these are the particular questions what we'll be discussing. So I'll start with this one. A ball is released from rest at t equals 0 in a lift. Okay, there's a ball. So here I'm releasing this ball from rest. This all everything at t equals 0. Fine. That starts moving down with an acceleration AL. So the lift what happen will start moving down. And the ball is released from rest. And the lift also will accelerate from rest. After what time the ball will strike either the floor or the ceiling that we have to calculate here. So I'll start this one. I'll give the information. The ball is released from rest, both t equal to 0. The moment we release, what are the things the weight mg will act? And the lift starts moving down. So after some time, what we see is just for our convenient purpose, we are taking this one after some time. This is it after some time t. I'll assume that the ball will come and strike and the lift will have some velocity. This is what happens to the ball. This happens at time t. Now we have to calculate this particular thing. So what is the lift? It has this particular thing has ascended. I'm taking some reference pointer. What is the reference point? I'm choosing I'm assuming that the ball will strike the floor. After some time, what happened where that particular floor is here? And I'll give the red some color for it. After some time, look at the floor of the lift. How much of height it will descend? It will descend h. Similarly, what happens to the ball? The ball will move from here to here. There's a distance moved by the ball. It's all about, see, like, hey, we should have this imagination. We can't just write some formula. We should understand what actually happening. Then we'll go for it. So it is going to have the free fall acceleration. The ball will fall freely. Then what is our entire formula? We are discussing the first case. When the lift is moving with an acceleration 9 meters per second square. Whatever the acceleration of the ball, 10 meters per second square. Both will accelerate from rest. Then what is the formula? Displacement of the ball with respect to lift. Lift means I'm writing 1, this 1. I'll write it. Final minus initial UBL time taken plus ABL t square. The equations of motion only we are writing in this way. Then what is the final position? What is what do you mean by SBL? Position of the ball with respect to floor of the lift finally at time t. What do you mean by SBLI? Position of the ball with respect to floor initially. So how you write SBL? It should be like a SBF minus. So we are going to write this. There's a first problem. No, let me expand here. AB minus AL T square by 2. Finally, where it is, the ball, this is a final. This diagram is final. This diagram is initial. So shall I'll take downward as positive. So plus H, plus H. Initially, ball at what height it is? Minus 10. This one, this one. This distance, because all the distances I'll measure this one. This is H equals 0. So where the ball is? Ball is at a height of minus 10 meter. No. Why plus H? Because we are measuring anything downward, we should take it as positive. Anything upward, we should take that as negative. And this particular point is H equal to 0. Okay, are you justified? This one, then minus of. Let me increase the font size. Minus of this one. What is the left initially? Now you have to ask questions of why you are writing this 0. I'm taking this reference. Where is the floor of the lift at equals 0? At H equals 0 only. So I'm taking this floor as 1, L I'm writing it, equal to initial velocity of the ball, 0. Final velocity of the ball, 0. Acceleration of the ball or bolt, anything, ball or bolt, both are same. What is the initial acceleration of the, what is the acceleration of the ball? G10. So we'll write it here. Plus 10. Acceleration of lift is how much? Plus 9. Whole divided by square this one. Now you have to ask questions are why you are writing those accelerations. I think visible. No, see the things. This one I'll highlight it. So why you are giving signs? What is the how the ball will accelerate downward? So this will be positive. And what about the lift? Lift is also accelerating downward. This is also positive. So both are positive. Anything directed downward will be positive. So why this is negative? Because you are measuring displacement all from the initial portion. So why you are taking that one? I'm just assuming that the ball may strike the floor. I'm assuming this point. Okay, anything upward, the either displacement, velocity, acceleration should be taken as negative. So why this is plus H? After some time, where the when the ball is about to strike the floor, what about the ball and the floor? They are at same position from the reference level, no? So we are writing plus H plus H. If you want, you write it here. What is this? This point will be origin. Okay, fine. So we'll substitute all the quantities. This will be 0. This will be plus 10. This bracket term I'll write 0. There's a first problem. In detail, I'm trying to write all the things. So 10 minus 9, how much will be 1? This will be t square by 2. So this will be 10 equal to t square by 2. T equal to root 20 seconds. After what time the ball will come and strike? After root 20 seconds, it will strike out 2 root 5 seconds. What will be the velocity of ball and the lift at this point? You can calculate. Velocity of ball, gt, 10 root 20 meter per second. Acceleration of the velocity of the lift when ball is striking, AL into T. This will be 9. These velocities we have calculated. So we got time positive. What do you mean by positive? What does it indicate? Ball strikes the floor of lift. There's a meaning. Okay, sir, if I get negative, what we should conclude? If I get negative, then what we should conclude? Then not possible. If you get time positive, the situation is what you assumed is right. Time negative means the situation is not possible. I think this is very important. If you get time positive, then what you assumed is right. If you get time negative, what you assumed is wrong. So assumption is, what is assumption? That ball will strike the floor. See, I was not knowing whether ball will strike the ceiling or the floor. We don't know. We just made an assumption. I just assumed that the ball will strike the floor. I got time positive. Then what I assumed is correct here. We'll choose the second situation. The same thing. If the lift is same diagram,